Calabresi, and I'm a PhD candidate in Electrical, Electronics and Communications Engineering at Politecnico di Torino. Today I'm going to talk about a new kind of technology that will be used in the future for digital electronics applications. In particular, this technology is named quantum dot cellular automata, and it is based on the so-called quantum dot cellular automata cell. In particular, this cell is composed by 4 quantum dots that are basically 4 containers in which we can put 2 electrons, 2 charges. The particular characteristics of these 2 charges is that they have the same charge, the same value of charge, and for this reason, since they are both negative, they repel each other. That means that the 2 electrons in this configuration, in this cell, will be in 2 possible configurations that we will call logic 0 and logic 1. In particular, having 2 types of cells, 2 configurations, allows us to encode an information. That is the basic principle of digital electronics, the fact that you can encode some information in stable states. In standard electronics, this is based on conduction. So basically, if you have a wire and there is a current inside this wire, so you can say that there is logic 1. If there is no conduction, there is no current, so you can say that there is logic 0. This is a completely different paradigm. And we can, for instance, create this kind of cells using magnets or molecules. Just to give you an example, here we have 2 1,4-dialyl butane molecules that are oxidized. In particular, these 2 molecules are without 1 electron, so they are positively charged. And for the same principle, the 2 positive charge will be on the antipodal sides of these 2 molecules. Therefore, create a stable configuration that will be used in this case to encode logic 0. Of course, we can also have the opposite configuration that will be used to encode logic 1. Here we have a first proof of concept that for us is useful only to explain the paradigm. Basically, we have 3 cells, 3 quantum dot cellular automata cells, and we have this configuration, this square configuration with the 2 electrons. What we can see here is that if we try to move the first cell, you can see that also the other 2 cells move. And of course, here we have an encoding of logic 0, logic 0, logic 0. What happens if I move the first cell that is named the driver configuration, the driver cell? What happens is that here you can see that also the 2 other cells align with the same logic. So we have logic 1, logic 1, logic 1. Well, you can imagine to have maybe thousands of these cells, and if I change the logic of the first cell, all the other cells vary accordingly. But the interesting point is that there is no electrical conduction in this mechanism, so there is no current flowing on this possible wire. This is the interesting point of this technology, because if you do not have any current flow, basically you do not have power dissipation due to Joule effect. That is one of the problems of the current MOSFET technology. So this technology aims to overcome the limitations of CMOS technology and will be one of the possible candidates for future digital electronics. What we do here in Politecnico di Torino is to give to the students the skill that will be used in the future to create and to design this kind of technology. Because this is completely different with respect to the paradigm which is used at the moment for the standard digital electronics, therefore requires different skills that starts from the basic physical behavior, that is Schrödinger equation or nanotechnology, and reaches the high abstraction level of software engineering. Thank you very much, and see you for the next videos.